All right. So I said UCM, right? We talked about UCM. UCM stands for Uniform Circular Motion. Good. So this is Unit 4 still. I told you about UCM. Can't find my eraser. There it is. And it stands for Uniform Circular Motion. Uniform Circular. Oh my goodness, how much time that's left? I know, Julian. Nice radio voice again. Love it. All right. So, uniform circular motion is the movement of an object around a circle at a fixed radius with a constant speed. So this is the movement of an object around a circle with a fixed radius . Yep, means the same radius. So the radius is constant. With a fixed radius at a constant speed. Okay. So the movement of an object around a circle with a fixed radius at a constant speed. Draw a good circle here. Not terrible. We'll go with it. Julian, you laughed, but I bet you can't draw one better. You probably can't. We don't need to prove it right now. You're a man of many talents, right? No. So that R stands for the what? The radius. Okay. So let's say this is our car going around an on-ramp to a highway or something like that. Okay. At that point, which way is the velocity? Or this could even be our bucket that I swung around my head, right? At that point, which way is the velocity? Pick one. There's two options. No, it's not to the side. I'm glad you picked one. What is it? Down. Maurice, what'd you say? Down. Perfect. Down. So at this point, velocity is down, right? What's the relationship between the radius and the velocity? Perpendicular. Good. So V is perpendicular to R. And I'm going to put vectors around them because R is actually a position vector. I don't know if we'll get into R being a position vector extensively in this class, but it's something we should learn. And remember, the upside down T means perpendicular. That means it makes a right angle, right? 90-degree angle. Now, if this is the bucket being swung around in the circle, right? That means this radius right here, this is my arm, right? Right? Which way did my arm pull on the bucket? Toward the center or away from the center? So right here, I'm holding the bucket like this. Which way am I pulling on it? Towards my shoulder or towards the wall? Towards me, right? Right? I applied a force in this direction, right? That force resulted in an, hopefully it'll be a hint, and begins with an A, acceleration, right? So what else do we know about A and V? Perpendicular, good. That's kind of a big deal, isn't it, Richard? Okay. If this right here is not the case, if V is not perpendicular to A, then you will not have uniform circular motion. All right? Because if there's a small part of A that's in the same direction as V, it'll either speed it up or slow it down. All right? So A and V must be perpendicular. They must make a right angle. What's the net force acting on the bucket as it goes around the circle? Do the second law. F net equals ma, right? So the acceleration is indicative of the net force, right? So which way is the net force? towards the center, right? The object experiences a force towards the center of the circle. We'll put in parentheses nets. Hopefully that gets you thinking about Newton's second law. So the object experiences a force towards the center of the circle. Does that make sense? Does anybody know the name of that force? What was it, John? Centrifugal? With an F?
Yes.
Yes, okay. Centrifugal. I'm glad you brought it up. Which was I was hoping when I was doing the bucket of water that you guys were going to say centrifugal. Right? Centrifugal. Let's see if I can spell it right. It's always an adventure. Yeah, you can connect. I had a physics professor called it centrifugal. That's how I remember how to spell it. I think it's right. I'll look it up. All right. Centrifugal. All right, John, is that what you're thinking right there? Does that look like it could be a spelling of the force you were alluding to?
Yes.
Okay. That force is actually it's called a fictitious force, and we'll explain what that is later. All right. But you're really close, and this is why it's confusing. Okay. Because the actual force was called a centripetal force. Michael, is that time already? I got 4 minutes, bud. Okay. So the force you were looking for, and it's really close in name and spelling, is centripetal. Okay. A centripetal force is a force towards the center of a, what do you guys think? Circle. And what do you think its acceleration is called? A centripetal force has a centripetal acceleration. If we give the symbol A little c. Which way is the centripetal acceleration point? Towards the center. We're taking a lot of notes today, I'm sorry. Towards the center of the circle. Right. I think that's where we'll end today. Before I let you go, I have got to give you the definition of centripetal. Centripetal means center seeking. Why do you think it means center seeking? Good. Not that it moves, but it's pointing towards the center. Okay. Centrifugal means center fleeing, which means it points which way? Away. Okay. All right. Any questions?